Good day, everyone. So, last time we have introduced the concepts on limits. Now we go to the properties of limits. So, what you can see on the screen right now are the list of the 9 properties. So, let's inspect them one by one before having some examples. Okay, so the first property is the limit of k, where k is any constant. As x approaches a is the constant itself. So the second one is the limit of x as x approaches a is a. Take note, the x here is the variable. Okay, so the limit of a constant multiplied by f of x, or a function of x as x approaches a, is the product of the constant and the limit of the given function as x approaches a. Then if we have two functions that are added together and we get its limit as x approaches a, so simply get the limit of each function as x approaches a and then add them. And then the fifth limit property rather is if we have a difference of two functions, we simply replace the plus sign with the minus sign. So do the same thing, just replace the plus sign with the minus sign. So get the limit of each function and proceed to subtraction. So number 6, we have a product of two functions and we get the limit as x approaches a. So we get the limit of each function and then multiply them. Then number 7, so if we're going to have f of x divided by g of x as x approaches a, so we get the limit of each function and do the division process. And below we have number 8. So if we have a function raised to the power of n and we get its limit, then we get the limit of the function before we raise it to a power of n. And then lastly, so if a function or nth root of a function, okay, is being evaluated by getting its limit as x approaches a, is you first get the limit of the given function as x approaches a, and then um, you get the nth root. So there's a limitation here. Take note that for radicals, make sure that the radicand is positive if the index is an even number. All right. So we now go to the examples. So let me show the list on the side. So for example, we have limit of 2 as x approaches 5. Okay, so we have the constant 2 as x approaches 5. So regardless of the value of a here, the limit is the constant itself. So the answer is 2. So if we're going to have another constant, let's say -7, as x approaches 10, okay, again, the answer is the constant itself. So it's -7. So now an example for property number 2. So if we have a variable x and we get its limit as x approaches -100, so the answer is the value of a. So the value of x that is being approached by, or rather the number that is being approached by x. Okay, so -100. So another example, again, make sure that there are no coefficients or no powers for the variable x. It's really just x. Okay, and then let's say we have a as 20. So as x approaches 20, so the limit therefore is 20. Okay. So next example is if we're going to put a coefficient before x, or we multiply a constant to x and get the limit as x approaches, let's say, -5. So using property number 3, we put the constant before the limit of x as x approaches -5. So we have 2 times, so the limit of x as x approaches -5, according to property number 2, is -5. So 2 times -5, or that's -10. So for the final answer, the final line of the solution, okay, make sure to rewrite the given. Okay. Next is, let's say, limit of -24x. Okay, as x approaches -5. So same thing, you write the constant and multiply it to the limit of x as x approaches -5. Or that's -24 times -5, because the limit of x as x approaches -5 is -5. Or if the function being multiplied to the constant is not x, yeah, let's say x squared, so you see other properties. Okay, so -24 times -5. Okay, that's 120. So the limit of -24x as x approaches -5. So make sure that the negative number is enclosed with parentheses so that you will not mistakenly read it as limit of, or limit minus 24x. It should be the limit of a negative number or value. So limit of quantity, -24x. All right, so another example, this time using another property. Okay, so if we're going to have x plus 7 as x approaches 0. Okay, so we use property number 4. Okay, so f of x plus g of x to get the limit of each function and then add them together. So add the result, not together. So get the limit first of x, and then as x approaches 0, and add it to the limit of 7 as x approaches 0. So limit of x as x approaches 0 according to property number 2 is 0. And then according to property number 1, 7 is a constant. So limit of 7 is 7. So we get 7 for the limit of x plus 7 as x approaches 0. Okay. And then another example, let me continue on the side. Okay. So we have example number 8. Number 8. Okay, let's say we have 5x minus 3. So the limit of, okay, cannot find the cursor. Okay, for a moment. Okay. So the limit of 5x minus 3 as x approaches, let's say -1. Okay. So using property number 5, so get the limit of 5x first as x approaches -1, and then subtract the limit of the second term, so 3 as x approaches -1. So using property number 3 and property number 2, so we have 5 times the limit of x as x approaches -1. So just keep writing limit of x as x approaches -1. So we'll put the value right away. So again, limit of x as x approaches -1 is -1, right? And then minus the limit of the constant is the constant itself using property number 1. So minus 3, so we have -5 minus 3, or that's -8. So the limit of 5x minus 3 as x approaches -1 is -8. So we continue. What if the given is a product of two functions? So the given x plus or x minus 1 times x plus 2, for example. So you have two options. Actually, you can get the product and then proceed to getting the limit of the product. Or you apply property number 5, okay, wherein you get the limit of the first function first, okay, as x approaches -1, and multiply it to the limit of the second function as x approaches -1. So we have the limit of x as x approaches -1 is -1. Okay, minus the limit of 1 as x approaches -1 is 1. Okay, and then multiply this with the limit of x plus 2. So limit of x is, as x approaches -1 is -1. And then plus the limit of 2 as x approaches -1 is 2. So it's -2 times -1 plus 2 is 1. So -2 times 1, or that's -2. Okay. So -2. So again, don't forget to write the given and have the solutions written vertically with the equal signs aligned, no, vertically, so that we can easily trace the wrong parts of the solution if ever there are wrong parts or incorrect parts or incomplete parts. So now using another property, so what if we are dividing two functions? Let's say limit of 2 over x minus 1 as x approaches 10. So limit of the numerator of the fraction, you divide it by the limit of the denominator. So x minus 1 as x approaches 10. So the limit of 2, so that's property number 1. Okay, it's a constant, so it's 2. And then the limit of x minus 1. So limit of x as x approaches 10 is 10. And then minus the limit of 1 as x approaches 10 is 1. So 2 over 9. Okay. And then using property number 8. So what if we have an x squared as x approaches negative 12? So we get first the limit of x as x approaches negative 12, raise it to a power of 2. Okay, so perform first the operation of getting the limit before you raise it to the power of 2. So limit of x as x approaches negative 12 according to property number 2 is negative 12. And then you raise it to a power of 2. So the square of negative 12 is positive 144, right? So take note that the square of a negative number is always positive. The negative 12 is being enclosed with parentheses. So it's different if we are going to remove the parentheses. Okay. So it's different if you write it this way. So this means na you need to square 12 first before putting the negative sign. So this is not 144, but it's negative 144. Okay. So just a quick reminder because that's a common mistake of students. So number 12, example number 12, an example on the last property. So if we're going to have an nth root of a function, okay, so let's say square root of x squared minus 5x plus 2. Let's combine all the properties or most of the properties. Okay. So we need to first get the limit of whatever is written inside the radical sign, or meaning the radicand. Okay, x squared minus 5x plus 2 all over x as x approaches 0. Okay, before we get to the extraction, meaning the square root. Okay, so using property number, what was that for the division? Number 7. Okay, yes, it's number 7. Okay, so we get the limit, okay, or square root of, so let's make it bigger. Wait, sorry for that. Okay, a limit of x squared minus 5x plus 2. Okay, as x approaches 0, and then divide it by, okay, the limit of x as x approaches 0. So we have the square root of, so let's just get the limit right away. So x squared, so using one of the properties, if you have an exponent, so limit of x first, as x approaches 0, then raise it to the power of 2. So limit of x as x approaches 0 is 0. And then you square it. Okay, minus the constant 5, then multiplied by the limit of x as x approaches 0, that's 0. Then plus 2. Okay, and then all over limit of x as approaches 0 is 0. So we have 0 squared, or 0 minus 5 times 0 is 0 plus 2. So it's basically square root of 2 over 0. But 2 over 0 is undefined. Okay, so the limit is undefined. Okay, meaning the limit does not exist. Okay, meaning there's no limit. So it's boundless, it's limitless. So I'll show on the right side, no, a graph. So if we're going to graph this, okay, using a graphing app to understand what this undefined limit all about. Okay, so if we're going to use a graphing application, a graphing software, so the function looks like this. Okay, so it says as x approaches 0. So I hope you can see this. Okay, so as x approaches 0, so this value is being approached by the function. So if we're going to look at the value of y that is being approached by the graph, no, the blue one, the blue curve actually, is the sketch of the function square root of x squared minus 5x plus 2 over x. Okay, so if you can see, okay, so there's no value of y that is being approached by the function. Okay, so if you will zoom this in, okay, going upwards, so as you can see, the blue curve is getting closer and closer to the y-axis. Okay, but we're going to zoom it out more. Okay, you can see that it is not crossing the y-axis. It's just getting closer and closer to it. No, but it's not touching it or crossing it. Okay, so meaning there's no limit. No, there's no value of y that is being approached, okay, by the, what do you call this? By the curve, okay, by the function. So that's what limit does not exist means. Okay, so the limit na is undefined, so it's not defined. So meaning there is no limit. All right. So that would be all for the properties of the limits of a function. So next topic would be the limits of or limits at indeterminate form. Limits in indeterminate form. Bye.